Assalamualaikum and good day. So today I will continue my lecture for topic 2 part 1 for subtopic 2.2 reactor. What is a power reactors? Power reactor are similar to transformer. However, they have only one winding per phase. Okay, they are employed primarily to control and regulate the reactive power of a power system by supplying the inductive and absorb the capacitive power. So this is the figure of the reactor as we can see here, and this is the diagram of the power reactors. Okay, next is the reactor types and applications. Okay, there are two types. Okay, two construction types. The first one is air core, air insulated types, and the second one is liquid insulated iron core types. Okay, this is the figure for the first construction types. Okay, and then this is the for the second types. Here is the applications of reactor. There are two applications. The first one is shunt reactors, either for switching, surge, limitation, reactive compensation, for steady state voltage or control or harmonics filters. And the second application is series reactors for fault current limitation. Okay, we can see here the first one is shunt reactors. We can see that the RSL is connected in parallel with the capacitor, and for series reactors, capacitor is connected in series with the RSL load. Okay, next is the application for series reactor. Okay, the rating of the series reactors can be determined by using these two formula. The first one is to calculate the QR. Okay, by using this formula, and then to calculate the SL by using this formula, where QR is rating of the series reactor in volt amp unit, and Vx is equal to rated voltage drop of the reactor phase to phase in volts, and I is the rated current of the reactor. Okay, here is the example 2.1 for reactor applications. Okay, consider a 3-phase reactor having the following specifications. Okay, BR is equal to 3 kV, and Vx is equal to 3% of the system voltage, and the system voltage is phase to phase, which is 3-phase system, and the system current is 650 amp. Okay, so we have to determine what is the Vx first. So Vx is 3% of the system voltage, so we have to times 3% with the 33 kV to get the Vx value, which is equal to 0.99 kV, and say we take 1 kV for our calculation. And then first we have to calculate what is the XL. Okay, SL value must be calculated in per phase value. Okay, by using this formula. Okay, this formula for SL. So we put all the value of Vx and also I, and we have to divide by square root 3 to get the value of XL in per phase value. Okay, this is the value of SL in per phase. Okay, next we have to calculate what is the QR for 3-phase reactor and also for single-phase reactor. Okay, for this formula, this is for 3-phase. So we just put all the value of Vx in 3-phase and also the I value. So this is the answer for QR size for 3-phase reactor. And then for single phase, we have to divide by square root 3 to get the value of single phase reactor, because this value Vx is in 3-phase. So we have to convert to single phase, and then we times with the I to get the QR value. Okay, next is the example 2.2 for reactor applications. Okay, consider a distribution system as illustrated, being fed by 2 power source in tandem. Okay, this is the system. Okay, we have a distribution system that is connected with a transformer and also a generator. Okay, this is the specification of the transformer, which 5000 kVA, step down 33 kVA, 11 kV, okay, having a reactance of 7.5% and connected to a power grid. And a generator is 2500 kVA, 11 kV, and having a steady state reactance XD is 25%. Okay, this is the solution. Okay, we have a 3-phase fault somewhere in the bus system without reactive compensation, ignoring the line impedance can reach a level of okay, this is the formula for fault MVA, okay, which is equal to base MVA divided by Z equivalent. Okay, we have fault here, and then we have a parallel circuit which is connected transformer with a generator. Okay, this is the parallel. Okay, and then consider the base level. Okay, consider the base level as 5000 kVA, 11 kV. Okay, this is the new base. Okay, we have 5000, and then for transformer, the MVA is 5000, so the value is same with the new base 5000. And then for generator reactance at new base, okay, we know that our new base is 5000 and the previous the existing value of MVA for generator is 2500. So we have to calculate what is the reactance at new base, which is 2 times with the previous reactance, which is 50%, because the previous value is 2500 MVA, and then the new base is 5000. So the value is increased from 25% reactance to the new one is 50% reactance. Okay, next we have to solve what is the fault level. Okay, before that we have to calculate first what is the equivalent impedance of the combined power system at the point of fault. As we know, the fault occur with a parallel condition of transformer and also generator. So we have to calculate what is the Z equivalent by using this formula. This is the equivalent formula for parallel Z. So then we get the Z equivalent is equal to 0.0625 per unit. And then by using this formula, for fault, we can determine what is the fault level, which is equal to base divided by Z equivalent. Okay, next question is, if the fault level is required to be limited to 50 MVA, a series reactor of reactance percentage of X may be introduced into the transformer circuit. Okay, because of the fault level is decreased from 80 MVA to 50 MVA, then we know that the Z equivalent also can be different. So we have to calculate the new equivalent impedance for the fault level of 50 MVA. So by using this formula, okay, and then we can calculate what is the Z equivalent new, which is equal to 0.1 per unit. Okay, because the level of fault is limited to 50 MVA. So the Z equivalent is 0.1 per unit. And the new reactance, we have to calculate what is the new reactance. Okay, by using the formula of parallel reactance, we can get what is the value of X new. Okay, which is 0.0535 per unit, or 5.35% at 50 kVA base and 11 kV base. Okay, thus series reactor of reactance 5.35 may be used to limit the fault to the required level. Okay, that's all for reactor. Is that? Thank you.